So let us now summarize the step 2. The step 2 basically is trying to follow the necessary motion to transfer one frame to the next. Now assuming that we are at the frame xn zn, we need to go to the frame xn plus 1 and zn plus 1. So the four steps that are the four sub steps that are there in step 2 I have defined here. So we are having rotation with respect to zn theta n, that is this has to move in theta n plus 1 direction, and for that this is the step that we write, and this has to be done in such a way that xn is going to be parallel to xn plus 1. See, there has to be a certain kind of imagination that has to be there, which I believe most of the engineering students who have done engineering graphics will have up till now, so that they can imagine, okay, if both the axes are going to be parallel or not. It has to be imagined in 3 dimensions. So this is the first step. So rotation with respect to Zn, we have to make a turn of theta n plus 1. See here, theta n plus 1 is positive because I have taken it in anti-clockwise direction. If it would have been in clockwise direction and I would have taken this route, I would have gone in the clockwise direction to reach the same position, I would have taken the angle as negative. So remember it, for anti-clockwise with respect to z axis it is going to be positive, and clockwise it is going to be negative. So the next step is when we after we have reached sorry this is yeah after we have reached after we have made xn parallel with an plus 1, the next step is to move the origin of frame n plus n to the point where an plus 1 meets with zn. So where dn plus 1 is the distance between the common normals of an and an plus 1. The common normals an and an plus 1, the distance between that is dn plus 1, and I had already told an and an plus 1 are perpendicular to dn plus 1, so it is the shortest distance again here. So this step, what it will do, what it does, it makes the xn collinear with xn plus 1. So that is the second step. The third step is when we translate this origin of frame n so that it coincides with the origin of frame n plus 1, and for that we have to move a distance of an plus 1, and that is the translatory an plus 1, so that now we are having xn and xn plus 1 overlapping each other, the origin also overlapping each other. Now what is not overlapping is the z axis. The zn and the zn plus 1 may or may not be overlapping each other. In that case we have to do the third one, the last one, the fourth one, which is we have to turn Zn with respect to x axis. So we are rotating with respect to xn plus 1 an angle of alpha n plus 1, and that turn will bring the final overlapping of frame n and n plus 1, and with that we will have shifted a frame from xn zn of joint n plus 1 to the reference frame xn plus 1 zn plus 1 of joint n plus 2, and mathematically we can write it as post multiplication. It's not pre-multiplication, it is post multiplication. So what will we write? The transformation matrix of n plus 1 with respect to n. Why? Because we always write the frame name here. We don't write the joint name. This should be very clear. We always write for transformation matrix the frame number. We don't write the joint number. So here we are trying to transform the frame n plus 1 with respect to n, and we write a short form for that, which is an plus 1. And with that, the 4 steps that we have, that we will write. Mathematically, how this will turn, that we will have to look in the next video. Thank you.